So today is very exciting class because most of the students having the problem to analyze circuit. Before analyzing the circuit, we have to understand some very basic and conventional law of electricity or basic topology to start the journey of analyzing the electrical circuit, right? So very first one, we would like to learn the Kirchhoff's current law, which is KCL, commonly known as KCL. Anyways, what is KCL? So this is actually a circuit, a very small portion of the circuit, and this one is node, right? So what Kirchhoff's current law state, the algebraic sum of currents entering a node or junction. So this is actually a node or junction. The amount of current entering, so I1 is entering, I2 also entering, and I3 also entering, and I5 and I4 is leaving. So the KCL states the summation of I in is equals to summation of I out, right? So I in means I1 plus I2 plus I3. The total entering current, this three, which is equals to I out, so I5 and I4. So is equals to I4 plus I5. That is actually saying here I in is equals to I out. And we could write down here like I1 plus I2 plus I3 minus I4 minus I5 is equals to 0. So the total summation of the current within the node is equals to 0. So this is actually KCL. Here is an example. So this is a node A or junction A, and there is another junction B. So the current is entering I1, another one is I4, and which one is leaving? I5 is leaving, I3 is leaving, and I2 is leaving, right? So here the expansion of the example with a value, so I1 is equals to 4 ampere, 1 ampere, 2 ampere, 3 ampere, right? So let's try with the example first. This one, I mean, these are both are same, but this is actually the basic equations we can draw from the circuit. So which one is entering? So I1 is entering, another one is I4 is entering. So entering current I1 plus I4 is equals to which one is leaving? So we could write down I2 plus I3 plus I5, right? So this is actually the equation for the given image. And this one, so I1 is equals to 4 ampere, which one is entering at node A, and I4 also entering. So there is no I4 given, so we have to calculate how many or how much current is entering at node number B, which is the value of I4, equals to the value of I2 is equals to 3 amp plus 2 amps and 1 amps, right? So I4 is equals to, we could write down here 6 minus 4, so it will be 2 ampere, right? Now let's try, or let's examine my result is correct or not. So we could write down the entering current and the leaving current. So leaving current is 6 in total, so here obviously 4 and 2, so this is also 6. So the total entering current in is equals to I So this is actually the example of. And the second one is KVL, Kirchhoff's voltage law. So Kirchhoff's voltage law state that the sum of total voltage drop within a closed circuit. So this is a circuit here, resistor number 1, resistor number 2, resistor number 3, and resistor number 4. And of course, here the voltage VAB, here voltage BC, likewise voltage CD, and of course voltage DA here, right? So these are the voltage drop within the enclosed circuit. So by the law of KVL said, the sum of voltage drops in the closed loop of this circuit is 0. It means that the first one is VAB plus VBC, VCD plus VDA is equals to 0. It means that within the circuit, the enclosed circuit, this one, the total voltage is equals to 0, and the total voltage drop within an enclosed circuit is VA, VB, VCD, VDA, right? And obviously within this circuit, the same amount of current is flowing because of this is a series circuit. We have another video for series and parallel circuit. Okay, so the another important rules will be VDR, voltage dividing rules, right? So here is the input voltage V in, and this two resistor is split into two portions, right? So this is one V out, another could be here as well, V out 2, and this is, let's say, 1. So the V out is equals to, we could write down the total resistance here. One is R1, another one is R2. So let's write down here R1 plus R2, and we have to find out the value with respect to this resistor. So here definitely this R2, and here the V in. Same as if you like to find the value for here, the voltage V out 2 is equals to, let's write down V in, and bottom will be R1 plus R2, and the reference one is R1, so we have to write down the value of R1. This is actually the VDR. So another important rules is current dividing rule, or CDR. This VDR and CDR actually used for parallel circuit. In that case, here as well, a parallel circuit here, and for CDR we have to understand the node, right? So this is a node, let's say this is node A, and this is the source of potential and obviously current flowing through this direction, and that is actually I. And at node, the current I is split into two portions. One is going up to this direction, and that is I2. Another one is going through this R1 resistor, that is I1. And in that case, the I1 and I2 are actually the splitted current from the I, the total current. So now if you'd like to evaluate the value of I1 and I2, we have to use this formula. So I1, it means this current which is going through the resistor R1. So I1 is equals to the total current I, times R2. It means not this resistor, we have to count the opposite resistor R2 over the total resistor R1 and R2. Same as I2 is equals to total current times the resistor R1, which is opposite resistor from the I2 over R1 plus R2. So this is the very basic equation for CDR. Hope you understand. This is actually a practice. Let's have a practice of this equation. Let's try the value of R1. Let's consider 50, and here let's say 100 ohms, right? Okay, and here the total current, let's say 10 amps, just an example, because we have to analyze this circuit, or we have to evaluate the equivalent resistance from this circuit, then we can calculate the total current, and of course that is depends on the potential source. Just consider the current here, 10 amps, right? So what will be the value of I1? So this 10 ampere will be split into two portions. One is I1, another one is I2. So I1 is equals to total current, right, times, so the total resistance is 50 and 100. So here will be 50 plus 100, and here will be 100 ohms, the opposite resistance of R1, right? And I2 will be same as total current, here 50 plus 100, and obviously the I2 opposite resistance will be 50, so we have to write down the value of 50. Let's calculate by the use of calculator. So here the total current for I1 is 6.667 amps, and here will be 3.333 amps, right? It means let's use the current I1, right? So I1, here we can see the resistance is 50, which is less, right, compared to this 100 ohms at R2. It means that I1 low resistance, more current. That's why here is 6.6667 amps, and I2 will be less current, right, 3.333 amps. And here another very interesting fact, because of the interesting numbers we have chosen, here is 50 ohms and here is 100. It means double. It means at I1 is double current flow with compared to the R2 resistance, which is 3.33, and here is 6.667 amps. Hope you understand this example. For this circuit, we are trying to analyze the current and the voltage of each branch and each of the resistor, right? So here is the voltage source or potential source. So here actually the picture present. Let's start. The topic is star delta conversion. So this is actually the delta connection and the star connection. How we understand the delta connection is because delta connection have actually the three resistors or three components, and this is looks like delta, and obviously it will be a loop inside the circuit, and we can't solve this problem because of this loop. Indeed, we have to convert to star connection. Whatsoever, we'll discuss more in details in another video. Now, today's lecture, we actually convert the delta to star or star to delta. Let's start from star to delta. Indeed, what we have to do, we have to let's create a star connection inside the delta, same as this one. So from here, let's draw a resistor. This is the common neutral point for star connection, and as well as there is another resistor. So this is RA, this is RB, RC, and this one RB, right? So RA is equals to all the three registers RAC, RAB, RBC added, RAB plus RAC plus RBC, and RA is this one, right? So the RA sidewise two register has to be taken into account. One is RAC, another one is RAB. So here need to be write down RAB multiply with RAC. Let's give another example. Say let's write down RC. Which one is RC? This one is RC. So RC is equals to denominator same as RAB plus RAC and RBC, and here which one is RC? This one is RC, right? So RC, RAC and RBC, the two register next to RC, so we have to count RAC here and RBC. So your task is to write down the RB and give me a comment, right? Now if we convert from star to delta, in that case we have to write down RAC. What will be the RAC in the context of RA, RC and RB? So let's write down RAB. Indeed, of course, at numerator we have to write down likewise RA, RB plus RB, RC plus RA into RC. It means we have to sum the registers like RA, RC and RB, like RA into RB plus RB into RC, RA into RC, right? Same as for RBC, same as before, we have to write down similar like RA, RB plus RB, RC plus RA, RC. Now we have to write down the denominator here in the context of RAB. Where is RAB? RAB is this one, right? Exactly from RAB, which register we can find? RC. So this is RC, right? So this one is RC. So we have to write down here RC. Hope you understand. Now try the RBC. Where is RBC? This one is RBC. So from RBC, which one we can see? We can see RA. So we have to write down here RA. So now your turn to write down RAC. Okay, this is your task. So you know the numerator will be same as this value. It means RA, RB plus RB, RC plus RA, RC. What will be here? It's your turn. Please make your comment, right? Thank you.